I got minus 2 cos 2x.
Good, so just using your rules here, looking at what's on the inside here, we've got 2x, we take the derivative, we get, but remember there's already a minus outside the front here, so we can keep that constant there. Take the derivative of that, we'll get minus 2 cos of 2x by keeping the division of that the same. Harry, part 2, what'd you get?
Part 2. Okay, negative 2x plus 3. Sine.
Oh, sorry, I think a lot when you were asking me about the negative thing, sorry, I was confused about what you were asking. So, this negative 5 isn't going to affect anything, but the fact that we're taking the derivative of cos is that that negative will affect it.
I was saying like the derivative is
Yeah.
2x plus 3.
Yes, right, it is 2x plus 3, yeah.
Does the minus apply to both terms?
Oh,
Minus 2x minus 3. Or just minus 2x plus 3.
okay, so the way I'd write it is, because I know the derivative of cos is negative sine, I'm going to put the negative here, and then the derivative, right, so the derivative of this, Harry, you said was, yeah, was 2x plus 3. I would actually just leave it like this. You can expand it out, okay, but I'll just leave it like this. But technically it is minus 2x minus 3, yeah. Yeah, and then sine of x.
Isn't the same multiplying the whole both those by that?
Yes, that's right.
Yeah, so if you get rid of the brackets.
And then if you go rid of the brackets, you still have to have brackets there anyway. Yeah, so there's no point really expanding here. Part 3. Kyle, what you got for me? Have you had a crack at this one? Let's do it together anyway. No, Kyle's doing it. So, derivative of sine. What are we looking at for the derivative of sine? Go back to over here. What does it become? Just if we had normal sine, it become cos, yeah? So we can start with that as a basis. If I ever have a constant there, I just usually leave it, right?
What's the derivative of x over 5?
But then, what are we looking at? What's the function inside here, Kyle, that you can see?
Oh my lord.
X on 3, right?
Yeah.
How do you find the derivative of that?
Oh, doesn't that become like an... I don't know.
Not too sure?
Could you... Oh, no. I see what you're saying.
Have a stab. Sorry, a product rule? When do you need the product or quotient rule? Good question.
When there's two functions.
When there's two functions. If you just have a number and a number and an x, don't usually require it, right?
You could separate it for material 1 on x. Oh no, 1 on 3 times
Good.
x.
Yes, and that's easier because if you write it as 1 on 3x, that's just a number in front of x, and when you take the derivative of x, a single power, what happens? It just goes away, right? Because you're subtracting the power by 1, it just goes to 0. And so the derivative of this is actually just 1 on 3. It's just a constant there. So when we come back to this one now, the derivative of 6 sine of x on 3, that's just going to be 6 times 1 on 3, and then cos of x on 3. Okay? And then that would just simplify out to 2 cos x on 3. Is that what you got, Laura?
Yes.
Yes, it is. All right, Emily, next one, part 4. You got one for me?
No, I haven't.
All right, well, let's work it out together.
Well, the first part equals, like, if you look at this minus sign,
Yep.
can you just, like, divide it into two things?
Yeah, and what would that be?
So minus cos.
Yep, that's right. So it's just like treating it like a constant, right? Like if you had a minus sign here, that would transfer over there as well. So no reason why you can't just do that. So the first part is minus cos of x. This is getting a bit messy. Okay. And what about the next bit?
Plus sign of it.
Exactly right. Same thing, right? If you have minus cos of x, that would just be negative sine of x, which is just a positive. Okay? So that would just be plus sine of x. Alright, so that's the first 4, differentiate. And I haven't done an example, but like the same other rules apply. We're talking about product and quotient rule, still got to know when to apply each one. Just being careful, like with your logarithms, if there's something funky going on inside here, you have to be aware of that. So if they have 2 functions multiplied here, if they have a fraction with 2 functions, then you have to, yeah, just be aware of that.